In this video, we will discuss finding the equation of a circle from a graph. Now, the general form of the equation of any circle is x minus the blank squared plus y minus the blank squared equals the blank squared. So for our standard form, this is the x-coordinate of the center, the y-coordinate of the center, and the radius. Now, for this problem, we can identify that our center is located at 3, -1. So our center is 3, -1. And our radius is the distance from the center to a point on the circle. And since it's exact, we can just count. So in this case, since we're going over 2 boxes, and the boxes increase by 1/2, I'd be going up by 1. So the radius equals 1. Now, if I want to use this in the equation, we know the x-coordinate of the center is 3. So I can fill in a 3 into the first blank. Then the y-coordinate of the center is -1. So you can fill in a -1 into the first blank. And the radius of the circle is 1. So you can fill in a 1 into the last blank. Now the last thing we have to do is simplify this. So for the terms of what we have here, it'll become x minus 3 squared is going to stay the same. The y minus -1 becomes y plus 1 squared. And 1 squared is equal to 1. So we can simplify, so our final answer is as shown. Now, these examples don't always work out as nicely as we had in that problem. In the cases we see in the Khan Academy examples, we have a center located at 5, 0, and then we have some other point, which we don't know what it is, but we have a point at 9, -1. Now, from there, we need to figure out what the radius is, because we know the radius is going to be this distance. However, because it's not a straight line, we don't know exactly what it is. But this allows us to use the distance formula for the radius. So remember, your distance formula is x2 minus x1 squared plus y2 minus y1 squared. So if I were to simplify that with the distance formula, I could call 50x1 y1 and x2 y2. So my radius equals x2 is 9 minus x1 is 5 squared plus y2 is -1 minus y1 is 0 squared. So this gives us the radius equals 9 minus 5 gives us 4 squared. -1 minus 0 is -1 squared. So 4 squared becomes 16. -1 squared is 1. So we get the radius equals the square root of 17. However, the square root of 17 isn't a perfect square, so we can't simplify this. So it has to stay exactly as is. So now when you're writing your equation of the circle, we have to fill in the x-coordinate, the y-coordinate, and the radius into the blanks. So if I were to do that, I can pull from what we have. We have the x-coordinate of the center is at 5. So I can fill in a 5. Then we have that the y-coordinate of the center is 0. So I can fill in a 0 for the y-coordinate. And the radius is the square root of 17. So you can fill in the square root of 17. Now for this, if I want to rewrite this in my final form, x minus 5 is going to stay the same. So it stays as x minus 5 squared. We really don't need to write the 0, so it becomes just y squared. And if we take the square root of 17 squared, square root of 17 squared equals just 17. So this becomes equal to 17. So this would be your final answer. For the next example, we also have a circle where we have to deal with the distance formula in order to find the length of the radius. So looking at what we have a center that's located at -1, 1. And I have a point on the circle that's located there. So the point on the circle, if we check our scale, this would be at 0, 1.75 because each of these are going up by 0.25. So the point would be at 0, 1.75. Now, in order to find the length of the radius, we're going to have to use our distance formula. So the radius equals, again, it's x2 minus x1 squared plus y2 minus y1 squared. Then if I substitute into the formula, so I can use center as x1, y1, x2, y2. So it becomes the radius equals x2 is 0 minus -1 squared plus 1.75 minus 1 squared. So this gives us the radius equals, the 0 minus -1 would become just +1 squared, plus 1 minus 1.75 is just 0.75, close parentheses squared. Now we notice that we have a decimal, however, long term is going to be easier if we change everything into a fraction. So rather than leaving it as 0.75, we're going to make it so it becomes, it's still 1 squared, and the 0.75 squared is really, 0.75 is really 3 over 4. So now if we continue to simplify, we get the radius equals 1 squared is 1. And if I had to deal with that 3/4 squared, 3/4 squared is really like it's 3 over 4 times 3 over 4, which gives you a value of 9 over 16, which can't simplify. So this would be plus 9 over 16. Now if I combine the 1 plus 9 over 16 and I change that to a fraction, it's going to give me that the radius equals the square root of 25 over 16. Now we can try to simplify the radius. So in order to do that, it becomes that the radius equals the square root of 25 over the square root of 16. The square root of 25 equals 5, and the square root of 16 equals 4. Now using all this information, we can rewrite it in our equation. So we have x minus the blank squared plus y minus the blank squared equals the blank squared. So if I substitute, you have the x coordinate of the center is -1, so minus -1. The y coordinate of the center is 1, so it's -1. And then the radius is a value of 5 over 4. So if I simplify, the x minus -1 becomes x plus 1 squared. The y minus 1 stays as y minus 1 squared. And if you want to deal with this 5 over 4 squared, 5 4 squared is really like you're multiplying 5 over 4 times 5 over 4 which gives you a value of 25 over 16, which doesn't simplify. So this be equal to 25 over 16 as your final answer.